My name is Dr. Matthew Balhoff. I'm an associate professor in petroleum engineering at the University of Texas at Austin. The purpose of this series of videos is a review of Matlab and Matlab programming. So the primary purpose is as a supplement to my PGE 323 reservoir simulation course, as just kind of a crash course and reminder how to do Matlab, but it also serves several other purposes. It could be used in other classes. It could be used as a supplement for a long Matlab course. It could be used as an introduction for new graduate students who haven't used Matlab or it's been a while. The most important thing is that these lectures will be extremely hands-on, and it will only be useful if you're following along with Matlab while we go through the slides and the example problems. So that's the first most important thing. So what I would recommend is to have two computers out, or maybe one iPad or something and a computer out, one with the video lecture on it, so maybe your tablet, your iPad on it, or another computer, and a second one with Matlab on it. That is the only way that it's useful. If you're a student at the University of Texas, I don't know the details, but I know that there is a virtual Matlab where I believe you can log in remotely and use it at any time. There's also student versions of Matlab, which are traditionally about $95. You can buy them in a computer store at UT, or if you go online to mathworks.com, you can purchase a student version, an electronic student version for $95 or around there. So before you get started, get Matlab up and be able to follow along as we do this. Otherwise, these videos won't be very useful. The few other points I'd like to make is that I do have some supplementary material. One of them is the slides that I've got. As you can see, the review of basic Matlab programming. So those are some very simple PowerPoint slides, which I will try to make available. And there's also some example problems, so some documents, whether it be matlab.m files, text files, Word documents, those types of things which might be useful. But this series of lecture will cover basic Matlab programming and also do a review of systems of equations, which is really important for my reservoir simulation course. Also, systems of equations gives us some pretty good examples to do some Matlab coding on. So make sure you've got Matlab up and running before we get started. The last thing I'd like to say is that the beauty of the video lecture is that you can move at your own pace. So if I go too fast, no big deal. Pause the program and try to catch up. Or rewind it a little bit and try to catch up. Or go all the way back to the beginning and start from scratch and watch it all over again. So no matter what your pace is, no matter what your skill level is, you can follow along and do it from the beginning. And anything I type, you should type in Matlab. Or anything I write down, you should write down and follow along. There'll also be some slides that I have which have Matlab commands. Type those into Matlab and make sure they work. And if you can't get them to work, then pause it, start all over again, and see if you can get it to work. But you need to be following along and doing that. So with that said, I'm going to get started. And these are the slides I'll follow a little bit of. But let's start out by opening up Matlab. So Matlab is going to be this icon down here. And so, or it might be in your folder here, and you can find Matlab. See if we can find it. Okay, so open up Matlab. Okay, and this is what we call the command window or the interactive node. All right, and so that's what we'll start out by learning. The first thing you'll want to do is make sure you're in the right directory. So this is sort of the default directory, but maybe you've got your own folder on the desktop or something, you want to change that. So I'm going to actually work out of, I've got a folder called Matlab Review Programming that I made, and I'm going to work out of there. But you can work out anything. If you wanted to work out of the desktop, then that'd be fine. Okay, but just choose, or you might want to make a new folder to do that, whatever, but just find your folder, and I'm going to work out of there. But this is where we're going to work, and this is the command window, and you see it's got the two prompts right over to the left, and Matlab works just like a calculator. It's a fancy calculator, that's all it is. So 2 plus 2 is 4. All right, so this answer is 2 plus 2 is equal to 4. I can say 2 times 3 is equal to 6. 2 divided by 3 is 0.667. 2 to the third power, I use the caret there, is 8. Right? I can do or I can do e to the 1, for example. That's 2.7183, or I can do e to the 3, and I get 20. Okay, so that's just that. I can do logarithms. So if I want to do ln, I don't type ln. I actually type log of, I type log. Log is ln. Okay, so log of 2.7183, okay, is 1, right? So the ln of e is just 1. Okay, if I want to do the log base 10, then I do log 10. And it'll give me the log base 10. So log is really ln. Log base 10 is what you usually consider as log. So some of the things are obvious. Some things you just kind of need to get used to. And maybe you need to look up on Google or on the help command or something, or just experience. You could do the sine. Everything works in radians, by the way. So if you want to do sine of 3.14159, that'll be 0 is the sine. Okay, it's not exactly 0 because it's not exactly pi. Or you could do the cosine of 3.14159. Okay, is minus 1. Okay. There's a little trick, which is the cursor up trick. So if you take your keyboard over here, then you got your cursors over here. This is a trick that you really need to get used to. If you use the cursor up, it brings back the previous command. And if you want to go to, if you keep on pressing cursor up, it goes back to other previous commands. So if I want to retype something, and I don't really feel like retyping the whole thing again, I can just use the cursor up. So let's say I had sine, and I actually want to do cosine now. Well, I could have just done the cursor up and change that. And done that, okay? Or maybe I want to do tan. Let's see if tangent works. So I use the cursor up button all the time. Remember, you got those 4 cursors. You want to press the one up, and it goes back and finds all the previous stuff. So that's really useful. Okay, so let me show you another thing. When I do 2 plus 2, it comes back as answer, ANS. But maybe I want to store it as another variable. So I want to call it x. X is equal to 2 plus 2. That gives me 4. Y is equal to 2 times 3. That's 6. Oh, I put a plus there, so y is equal to 2 times 3, and that's 6. If I wanted to say z is equal to x plus y, then I get 10, right? So that's x was stored as 4, y was stored as 6, so z is equal to x plus y. It's 10. By the way, if I can say w is equal to x times y, if I use the semicolon command after, it still does the computation, it just doesn't show what the answer is. So in this case, x was 4, y was 6, so w would be 24, but it doesn't show what it is because I put the semicolon after. That doesn't mean that it doesn't exist. If I type w, then it tells me it's 24. Right? Here's another neat thing. This is sort of new to programming. Or if you don't do a lot of programming. We said x was 4. I can say x is equal to x plus 1, and if you're not a programmer, you might think that that's really weird. How can x equal to x plus 1? X is equal to 4, x plus 1 is equal to 5, x can't equal to 5. That's not what we're saying. We're not saying x is equal to x plus 1. We're saying make x equal to x plus 1. So x was 4, now x will be 5. Right? So there you go. Or I could have said x is equal to 2 times x. Right? Now x is 5 now. It's not 4 anymore. We've already changed it to 5. So 5 times 2 will be 10. And it'll change it to 10. That's just what it is now. Right? Y still exists. Z still exists. W still exists. X is 10. Right? Okay. You can also make strings in Matlab. So you can say name is equal to mat. Okay, a string is just is characters. It's a fancy way of saying a word, right? Or I want to you could even put spaces in there. It's a longer. So that's how you do a string, and we might talk a little bit more about strings later, but we'll mostly deal with typical numbers. By the way, if you want to know what files are in your directory, you can type in ls, okay, and it tells you everything that's in there, right? So I've got these .dat files, I got some Excel files, I got some .m files, which are Matlab files, some text files. Okay, that's just the same thing as if I would have gone over to my folder here and looked at them. So these are all the same folders because I'm in that directory, right? So that was what ls does. It tells me ls means list the files in the directory. If I wanted to change the directory, or if I want to know what directory I'm in, you could do cd. That tells me that this is the directory I'm in, right? And you knew that too from up here. It's what we changed at the beginning. Okay, and you can even change your directory that way, or you could do it up here if you want. Either way. Another useful command is whos. WHOS. What it does is it tells you all the variables that you've got currently stored and how big they are. How many elements are in them. So remember, we were doing some stuff with ANS. So ANS, W, X, Y, and Z. So any of those exists. ANS was 4, W was 24, X was 10, etc. If I tried to do something like U, it would say undefined function or variable U because it doesn't exist. Okay, and if I thought it did exist, then I'd be like, wait a minute, type in whos, and you see, well, no, it's not there. So maybe I deleted it, maybe I never made it, and I thought I did, but it doesn't exist. So that's what the whos command does, and it's pretty useful. Now, there are, let me show you a few other things. If I wanted to clear the screen, I can type CLC. That clears the screen. Now, it doesn't clear all the variables. Okay, if I say what X is and what Y is, it doesn't know what it is. And whos looks just like what it is. It just clears the screen. It doesn't clear the variables, right? Now, if I wanted to clear a variable, I could say clear X or clear Z. I type clear Z. So if I say whos, Z no longer exists. So if I ask it what Z is, it doesn't know because I cleared it. If I wanted to clear all the variables, I would say clear all. Right? Now if I type whos, there's nothing in there. It's empty. So if I say X or W or Y, then they're all undefined. Right? So I cleared them all. If I want to clear the screen again, I do CLC. So now I'm starting with a blank slate. All right, let's so there are some built-in variables in Matlab. We've already kind of seen one. So if I say 2 plus 2 comes back as ANS, that's answer, right? So we created a variable called answer. What's another one? Pi, P-I. It's exactly what you think it is. It's 3.14159, okay, and there it is. And so if I wanted to find the sign of pi, it'd be better to do that than to just type it in, right? And we get 0. It's 10 to the minus 16 because a computer can only hold so many digits. So yeah, there's actually a lot more digits than I had before. Let me show you. And if you want to see how many digits there are in there, you can type in format long. Okay, and that's what pi is. Okay, and if I want to go back to what it was before, format short, that doesn't mean it's using only those many digits. It just means that that's what it shows. All right. Sometimes I like to look at all the digits. Sometimes I don't want to see them all. So that's why you go back from format short or format long. So it uses the long notation or the short number of digits. What are some other built-in variables? Well, if I do 1 divided by 0, that's infinity, right? So it comes back as INF, infinity. That's what INF is. If I do 0 divided by 0, that's undefined. So it's going to come back as NaN. NaN stands for not a number. Okay, and then we already learned about CLC and did some other things. If you ever, so I can only scratch the surface and talk about a few commands. Okay, I don't know all of the commands myself. Okay, there's thousands, if not hundreds of thousands of Matlab commands. I only know 0.1% of them. I know the ones that I use all the time. If I ever want to know something else, then there's a bunch of helpful tools. One of them I like to use is to go up to the help and go to product help. Okay, if you type in a keyword, something will come up. So if I wanted to type in pi, for example, okay, pi comes back. It says pi returns a floating point number of pi. All right, so, well, that was helpful. Okay, so if you want to type in anything, it would probably come up with the sort of things you wanted, or maybe similar things. And then a lot of times, if I type in something, it might give me other links to go to find other similar commands. All right. That's one thing you can do. You can also use the help command. So if I say help pi, oh, misspelled that, help pi, then it comes back and there it is. So it tells you what pi is, tells you how to use it, tells you some other things. You can also use the look for command. Okay, when I say the look for, it finds all the commands in Matlab that have PI in them. Okay, you can see there's a bunch of them. Right? So there's a bunch, and it's going to take a while. But and then there's one last helpful resource that you can use when you're stuck in Matlab, and that's Google, right? So almost every engineering and science program in the world, okay, and I'm being completely serious here, is that probably 75 to 95% of the science and engineering programs in the world teach some sort of course on Matlab, and there are hundreds of thousands of people, millions of people maybe, that use Matlab regularly. So Google is a very good source. If you're ever stuck and you don't know how to do something, Google it, and almost always something comes up. So these sources are great. Google's also very good. I use Google all the time when I don't know how to do something. And believe me, I only know how to do 0.1% of things in Matlab, but I know that if there's something I want to do and I don't know how to do it, that there's probably a way to do it. Somebody else has done it before. If I go to Google or I go to one of Matlab's help techniques, then they'll show me how to do it. Okay, but we're going to teach you the basics here. What are some other things we can do? Okay, so let me stop there. I've kind of taught you some of that. Let's go to the PowerPoint presentation, and we'll talk about some of the things. All right, so we're going to start out by talking the general command window and special functions. Like what we talked about, Matlab has this interactive mode or command window where it stores all the variables in there, and we saw that. We would create a variable, store it in there, we could reuse it later on unless I cleared the variable or unless I closed out of Matlab, in which case it would get rid of those variables. But otherwise, they're stored in there. And some examples, and I know these are easy, but you should be, anything you see on my screen that you can type it into Matlab just to get used to it. So you can say A is equal to 5, B is equal to 2 to the third plus 6. That would be 8 plus 6 is 14. And then C is equal to A plus B. So 5 plus 14 should be 19. So then C would be stored as 19. Some variables are built in, as like we said. And we just went through a few of them. There's really probably thousands of built-in variables, and I don't know them all. But, again, I can look them up if I need to. The most powerful aspect of Matlab is its ability to use arrays. And arrays are collections of numbers stored as a matrix or a vector. Okay? And really, a vector is a collection of scalar values, and we've been using scalar values so far today. And a matrix is a collection of rows, right? That's really what a matrix is. And there's a bunch of different ways where you can define a matrix or a vector. So let's start out with vectors. Vectors can be row vectors or they can be column vectors. And the way you define vectors is with brackets. You say your vector u is equal to or v is equal to, right? And if you wanted a row vector, you separate those numbers by spaces. So in this case, then type it in on Matlab, go to your command window, type u is equal to bracket 6 space 3 space 8 bracket, and you get 638. That's a row vector. It's got one row and 3 columns. That's what it is. It's a row vector. It's a 1 by 3. It's a subset of a matrix. So it's really a 1 by 3 matrix, but it's a row vector with 3 columns in it. If you wanted to create a column vector, what you do is you separate by semicolons. Right? So this is a case where we've got 3.1, 4.2, 0.5, and 0.9. We separated them by semicolons, and we get this. Right? So you should type that into Matlab and make sure you get the same thing. What about matrices? Matrices work really the same way. So in Matlab, you can create a matrix, and it can have any number of n rows. It can have any number of m columns. In this case, it's got 3 rows and 3 columns, but it doesn't have to be square. Okay, right? It could be 3 rows and 17 columns if you wanted. But in this case, again, you separate on a given row, you separate them by spaces, and then you separate the columns by the semicolon, right? So in this case, if I did A is equal to 4, 6, 7, semicolon, 5, 3, 2, semicolon, 1 space 7 space 4, okay, what you get is you get that matrix. It's a 3 by 3 matrix. If I typed in whose, it would say A is a 3 by 3 matrix. All right, 3 by 3, 3 rows and 3 columns. That's exactly what we thought it was. All right. By the way, if you type in and you get mistakes, that's a good thing. Okay, that's the only way you really learn programming and do these things, is to make mistakes, try to understand what you did, and then fix it and get it right. Okay, I know it's frustrating to get mistakes when you program, but everybody does it. The best programmers in the world make mistakes. Just get used to it. That's how you learn. All right. Okay. Another thing you can do is a transpose. A transpose just turns it on its side. It turns the rows into columns and the columns into rows. So in this case, there's my A. I had 4, 6, 7 as the first row. 4, 5, 1 was the first column. Let's say if I say B is equal to A and put apostrophe. Apostrophe means to transpose it. Then I get B, and it's the same matrix except that instead of 4, 5, 1 being on that first column, 4, 5, 1 is the first row. 4, 6, 7 is over there. So the rows became columns, the columns became rows. That's what the transpose does. It's a neat little trick there. There are lots of built-in functions. All right, lots of them. I've shown, about 8 or 9 here. There's thousands of MATLAB built-in functions. I don't know them all. I couldn't teach you all of them if I did. Let me go through some of the common ones, okay, to give you an idea of how we do that. One of them is I. EYI makes the identity matrix. So it makes a matrix full of 1. So type that in. And if you say I of 4, then, okay, it's a matrix, so it should have rows and columns. But by saying just 4, it implies that you want to square a matrix with 4 rows and 4 columns. So in this case, it's got 1s all in the main diagonal. Okay, you didn't have to do that. You could have done 4, 5, and then it would have been 4 rows and 5 columns. You can try that too. Here's one I really like, is the rand command. That's a random number generator. So this creates a matrix of 3 rows and 4 columns. Let's do it. Let's do C is equal to rand of 3, 4. Okay, there it is. There's 12 random numbers, 3 rows and 4 columns. And what we're going to do is we're going to say that, okay, if you look at it, then you can see all those numbers are between 0 and 1. So it's a random number generator, but what it does is it's only between 0 and 1. So if you wanted a random number to go from 0 to 10, well, that doesn't really work. But you know what? If you're clever, you can do that. So let me say D is equal to 10 times rand 3 to 4. Okay, now it goes from 0 to 10, right? So I kind of scaled it. Well, what if I didn't want to go from 0 to 10? What if I wanted to go from -4 to 6? Well, I could say D is equal to 10 times rand of 3 to 4 minus, what did I say, from -4? Okay, -4. So what it does is it creates a matrix that goes from 0 to 10 of random numbers and subtracts 4 from everything. So now you can see that the smallest number is right around -4, right? It doesn't get any smaller than that. And the biggest number is smaller than 6, all right? So maybe I could have done a bigger sampling here. Okay, so it goes from -4 all the way up to almost 6 is what I see there, right? So that's how I can create random numbers. So even though the default is to pick a random number, and I could do a scalar too, right? If I do just rand, see if that works. Yeah, if I just type in rand, it gives me a random number between 0 and 1. So the default is to go between 0 and 1, but if I wanted to do any other number, you can just scale it. Multiply it by a number, or multiply it and subtract it, or add something like that. So you just need to be clever, and you can get it to work. All right, what are some other neat functions in MATLAB? Okay, I like the linspace command. What a linspace does is it creates a vector of numbers, and be really careful with the arguments. That's the things we put in parentheses. We call them arguments. So 0 is a start point, 100 is the end point, and the last number is the number of points. So if I wanted to go from 0 to 100 and space it by 10, so 0, 10, 20, 30, you got to be careful. My first intuition would think there'd be 10 points there, but there's actually 11 when you think about it. So you would say linspace 0. So if I said U, it's going to linspace 0, 100, 11. You get that vector U, which goes from 0 to 100. Right? So 0 was the first number, 100 was the last number, 11 was the total number of points. And I could have done anything. I could have gone from 100 to 200 if I wanted. All right? And then it does it like that. Okay? Or I could have picked 21 points. All right? And then it spaces it by 5 each. All right? So that's how you do that. There's something called log space. Log space is a little tricky. So if I do log space, we can do it over here, 153. Okay, what that does is 1 is not the first number right here. The first number is 10 to the 1, so it'd be 10. The last number is not 5, it's 10 to the 5th, so that'd be 10,000. And then 3 is the number of points. So if I did that, what you would get is you get 10, 1,000, and, 10 to the 5th isn't 10,000, it's 100,000. So 10, 1,000, 100,000, and they're spaced equal. In other words, that the logs of these are spaced equally, right? So log of 10 is 1, log of 1,000 is 3, log of 100,000 is 5, right? So that's how you use log space. Let me talk about some other built-in functions. I'm going to clear the screen. So let me say A is equal to rand 6, 4, 5, right? So that's a random matrix, 4 rows and 5 columns. If I wanted to know the size of A, I can type in size of A, and it'll come back as 4, 5. So obviously I knew what it was right there. I could look at it, but if it was a huge matrix, right, and I wasn't sure what it was, and I could just type in size of A and tell me how big it is. If you had remember U was this vector. If I wanted to know how big U was, I would type, so anytime I have a vector, I type in the length, and it tells me how long it is. So this one is 21. So the length of U is 21. It's got 21 variables in it. A few other ones. Ones command. So if I want to do X is equal to ones of 7 column 1, right? That's a column matrix. It's got 7 rows and 1 column. Ones just means that it's full of ones. Or I could have said B is equal to ones. It just fills it up with ones. Likewise, you could have made one with zeros in it. Just creates a matrix full of zeros. And those are both quick, useful commands. Let's talk about, so what do we have? We had A. I'm going to clear all my variables just to clear all. So nothing's in there now. So type in whose, and there's nothing in there. If I say A is equal to random 6, 7 again, I get 6 rows, 7 columns. So it's did that. Now, there's something called subscript notation. With subscript notation, what it is you can find out what the what row and column it is. So let's say I want to know what the second row and third column of A are. Right? And this is different from what I had in the PowerPoint. I use a different matrix, obviously. But in this case, the second row, third column should be this number right there, 0.1622. Well, that's what it is. So good. So if you use the parentheses, A2, 3, it tells me what the second row, third column is. Likewise, if I wanted to change A23, let me do this. I'm going to change it to something ridiculous that makes it stick out. I'm going to change it to 15. Put a semicolon there if I want. All right. Now I say A. Look, now it changed the second row, third column to 15. Okay, that's something neat. There's something that's called colon notation, and that allows you to extract entire rows or entire columns or parts of rows and parts of columns. So if I did A second row, but the whole column, that's 2, comma, colon, the comma, the colon, right? That means the second row, but the whole column. Or all, I should say all columns is what I should say. So it does all of that, right? Or I could have done the all rows, but the third column. So all rows, but the third column should be this right over here, right? It should be the 0.3371, 15. You know, it should be. Well, it should be this whole row starting with that one. So let me do that. And there it is. It's a 0.3371, 15. Okay. Now you can even do parts of it. Let's say I wanted to do I wanted to do row 2 to 4, and I want to do column 5 to 6. Well, that's rows 2, 3, and 4, and columns 5 and 6. So rows 2, 3, and 4, but columns 1, 2, 3, 4, 5. 6. So it should be good. That's exactly what it is. So it's kind of these variables in there. That was row 2, 3, and 4, but only columns 5 and 6. So it just gives that little subset of the matrix. That's how you can use the colon notation, and that's what I was given some examples of here with the subscript and colon notation. Clear on my variables and kind of start all over again. So now let's talk about some general matrix and vector mathematics, right? So if I had a vector u, and let's call it u is equal to 1, 3, minus 4. Okay. V is equal to say 2 minus 5. So I really hope that you're following along and doing this. If you're just watching it, again, you might think, oh yeah, that makes sense, but later on you're going to be making all sorts of mistakes. So I hope that you're typing everything I type in and following along. So u and v are both row vectors, and they're both the same size. They both have 3 columns in them, right? So if I wanted to, I could say w is equal to u plus v, and what it does is it just adds all those elements. So w should be 1 plus 2 is 3, 3 plus minus 5 is negative 2, minus 4 plus 7 is 3. That's exactly what I get. So w is 3 minus 2, 3. Okay, let me make another one that's called x, and make it 1, 5, 6, minus 2. All right, so that's x, and I try to do u plus x. I get an error, and it says that the matrix dimension must agree. Okay, I can't add 2 vectors that are different sizes. I try to add a vector with 3 columns to one with 4 columns, and that's not going to work. They're different sizes. It doesn't have anything to add, that 4th column, so it gives me an error. So they got to be the same sizes. Let me try something else. U plus v. Okay, it doesn't like to do that either, u plus v transpose. Because u and v were both row vectors, and v, if I transpose it, becomes a column vector. You can't add a row vector to a column vector. You can add a row vector to a row vector. You can add a column vector to a column vector. But you can't add a row vector to a row vector. You can multiply 2 vectors if they're the same size, and that's what's called matrix multiplication. So this was u, this was v. Okay, and you can do a dot product, which is u times v. And what that is that's going to give me, actually what I want to do is I want to do u v prime. All right, so if I had, now I'm going to switch over to the dot cam for a second to show you how this works. Let me write down first what the And remember, if I'm going too fast for you, just pause it and rewind it if you have to. So here I had my two vectors, u and v, and this was 3 elements and v was 3 elements. If I wanted to do multiplication, when you multiply two vectors, the first one has to be a row vector and the second one has to be a column vector, and then you'll get a scalar. So what I want to do is I want to do 1, 3, minus 4 times a column vector, which is 2 minus 5, 7. Okay, when you do that, what you get is a dot product. So it's 1 times 2 plus 3 times minus 5. That was 3 times minus 5 plus minus 4 times 7, that is what? 2 plus minus 15 plus minus 28. I think that's minus 41 if I did it right. I don't know if I did or not. Okay, but that's how you do a dot product. So it's got to be a row vector times a column vector, and they have to be the same size. U and V are the same size, but V is a row vector, right? So what I actually wanted to do is to transpose this. So let me go back to Matlab. And, oh, I didn't mean to clear all, but I just have to type it in again. So that was U. This was V is 2 minus 5, 7. Okay, so that's U and V. And if I do U times V, I get an error because you can't multiply a row vector times a row vector. But what I can do is multiply a row vector times a column vector, U times V prime, the apostrophe, and I get minus 41, which is what I calculated earlier. Okay, you can actually multiply a column vector times a row vector, but then you get a matrix, right? And that's like a cross product, and I don't use that much. So, but if you do a vector, a dot product with another row vector, with a column vector, you do that dot product, you get a scalar, and that's what we saw here, right? So you get a scalar, which is minus 41. All right. Well, what about matrices? So let me do create a couple matrices here for you. A is equal to 3, 1, 2, 2, 4, minus 2. Well, sorry about that. Doesn't matter. I'm just making up numbers here anyway. Say B is equal to, I'm going to keep it simple. I'm going to say B is equal to A transpose. Right? So I got A and I got B. You can add A and B together. Right? And that's simple. It's 3 plus 3 is 6. 2 plus 1 is 3. So I'm just going to, and you should know how to do matrix addition, so that works out fine. You can do scalars. You can say D is equal to 4 times C. Right? That works. You get that. Matrix multiplication. Right? I'm not going to go into too much detail about how matrix multiplication works. But let me come over here back to the dot cam. Say this is A and this is B. Okay. In order for matrix multiplication to work, what I would get is I would get a C matrix. And let's say that this has got n rows. So this is row 1, 2, 3, all the way to n. And let's say it's got m columns. So 1, 2, 3 to m. So this is an n by m matrix. And let's say B has got m rows. 1, 2, 3, all the way to m. And it's got 1, 2, and L rows, right? So this is an M by L matrix. Then when I do the matrix, and sometimes what I'll do is I'll do A11, A12, A1M, A21, A22, this is AN1, AN2, ANM, right? So I use those little subscripts in there. It's a little, and this would be my little B11, and this would be BML. If I do that, if I do matrix multiplication, then N by M times an M by L, in order for that to work, the inner dimensions must agree. What I mean is that the number of rows, the number of columns in A, that's M, must equal the number of rows in B, that's M. If the number of columns in A don't match the number of rows in B, I'll get an error. And what I'm left with is an N by L matrix. So this has got N rows and L columns. Okay? And if you forget how to do matrix multiplication, go look it up. Okay? It's in, go look it up online or something. But you should know how to do matrix multiplication. But let's do that. Let's go back over to Matlab. You know what? I'm going to clear all my variables again. And I'm going to make a 3, 1, 2, 3 rows and 2 columns, right? And now I'm going to make B is equal to, so let me do this first. I'm going to do A times A. So A is a 3, it's got 2 rows and 3 columns, and A's got, of course, got 2 rows and 3 columns. So if I try to multiply those together, the inner dimensions don't match, right? Because I try to multiply a matrix that's got 3 columns by something that's only got 2 rows. So if I do that, I get an error. All right, so that's not going to work. But let me create B, which has got 1, 2, 4, minus 3, 1, minus 1. That's B. So it's got 3 rows and 2 columns. So if I do A times B, okay, how big do you think this matrix is going to be? Okay, ask yourself before we type it in. So, well, it's going to be A is a 2 by 3 and B is a 3 by 2. The inner dimensions match as the outer dimensions, the 2 by 2 that we're left with. So I think we're going to have a 2 by 2. Well, that's neat. There we go. So we get A times B is our 2 by 2. And that's matrix multiplication. If you ever forget how to do that, then go look it up. Okay, I'm going to teach one last thing. Well, not one, but one more thing. And that's element by element multiplication. Okay, and this is something I think a lot of people struggle with, right? And with element by element multiplication, what we're doing is if I do, this is a case where, let me create C, which is going to be 2, 1, minus 1. So that's C, and this is A. So they're both the same size. If I try to do A times C, it wouldn't work. C times A wouldn't work because they're different sizes. I can't do matrix multiplication with these two. But what happens if I didn't want to do matrix multiplication? What happens if instead all I really wanted to do is multiply the first row and first column of C times the first row and first column of A? So that would have been 2 times 3 is 6. And then I wanted to do the second row first column of C, which is 2, times the second row first column of A, which is 1. And I wanted to do that for all the elements. I would call that element by element matrix multiplication. And while I can't do A times C, what I can do is I can put a period in front of there, and I get A dot times C, and I get that. Okay? And you could do division as well. Okay? Now, all that those are doing is it's just dividing each element by the corresponding element in the other matrix. So And A divided by C, when I use the period there, it's, if I wanted to do row I column J, then it's saying row I column J of A divided by row I column J of C. And that's how I do division. I did the same thing with multiplication. Okay, and that's different from regular matrix multiplication. I could even do an exponential. Let me see if that works. I don't know. We'll do, or a power, A to the C. It's probably a huge number. Right, there we go. So A to the C was going to be, remember, A was that and C was that. So I got 9 when I do it A to the C, because 3 squared is 9, and 1 to the 1 is 1, and 1 to the 1 is 1, and then 2 to the 4th is 16, and 2 to the minus 2 is 0.25, and 4 to the 3 is 64. So that's how I got that. Clear that, clear all. And so that's what I was trying to talk about in these slides. Okay, so these are slightly different examples, so if you didn't follow it, then go back and look at it. Another thing I wanted to point out, you see how on my slides I use this percent symbol, and it's in green? A percent symbol just means a comment. And from Matlab's point of view, it doesn't read any of that. It ignores it. Okay, that's just for me and you and for the reader. So if I go over here, I could have said, what did I say? That you, say A is, okay. I could have easily just done, and all that stuff in green after the percent symbol, MATLAB doesn't even, it ignores it. It pretends like it's not even there. And it still calculates A. All right. So that's why in some of my slides I've got these percent symbols, and you'll see me use more of it in the future, some of our other stuff. So this was using our A dot times B, and this is our A times B. You should understand what the difference is. And let's talk about one last thing before we take a little break, and that's to do reshaping matrices. So reshape, so let's say I create a matrix. I'm going to clear everything again. Clear all. I'm going to say A is equal to rand 4 rows, 3 columns. 4 rows, 3 columns, that's what A is in random numbers. If I said, let's create a new matrix B, it's equal to reshape A6, 2. What does this say? Well, first off, I'd like to point out, reshape is one of our first functions we'll use, and we're going to be using tons and tons of functions. Most of them we'll make on our own. Reshape is a Matlab built-in function. So somebody who works for Matlab created a function called reshape. And it does exactly what it sounds like. It reshapes a matrix, A, and it turns that matrix A into one that's got 6 rows and 2 columns, is the way I drew it over here, okay, instead of 4 rows and 3 columns. So my arguments are the matrix I want to reshape, the new number of rows, and the new number of columns. And it's going to create a matrix B. So it's got output is B, inputs are A, new number of rows, new number of columns. When I do that, it's the same numbers, but now it's just got 6 rows and 2 columns. Okay, and notice how it does it. It kind of goes down the column. So it starts out with that first column, 0.8001, 0.4314, 0.9106, 0.1818, but then it goes to the top of the second column, 0.2638, 0.1455, and so forth. That's how reshape works. All right? So I hope you're following along with that and do that. That's our first example of a function. We'll revisit function follows more. So that is going to be the end of our first part. So if you didn't feel like you understood everything in there, go back and watch it again. Okay? And make sure you're following by hand with your MATLAB stuff. These are some very basic commands. There are thousands, hundreds of thousands of commands in MATLAB. I cannot teach you all of them. I don't know all of them. But I know enough to get by, and when I need to know something that's not in there, I just look it up. I go into MATLAB's help or go to Google, and there's something out there that does what I want it to do more than likely. But these are enough to get you by. And what we're going to talk about next is input-output. And with that, we're going to take a short break and then start the second video.